maybe we can make a start. Hello?
Yeah, that sounds good.
So yeah, welcome everyone to DSC's fifth workshop. This will be our second to last workshop, and we will be one of the first workshops of the series for our final project, which is the 2048 game app. So Arnav, could you confirm if my screen is on share?
Yep, screen's on share.
Yep, so I will send a GitHub link for you guys to check it out. But this GitHub link will be kind of step-by-step guide where we'll be kind of following these steps to make the app. So this GitHub link has a few extra resources to tell you guys about the widgets that we'll be using, or the new widgets. We also have a link to a YouTube channel, and we have 2 parts to this workshop, and the code is inside the lib folder. So yeah, we'll first make a start on part 1, which is design the game logic. So to those who don't know, 2048 app, it looks something like this. You have a board, you have 16 tiles here, 4 rows, 4 columns, and you can go left, down, up, right, whatever. And the aim of the game is to try to get one of the tiles to be 2048. How you get it to be 2048 is if you merge tiles together. For example, this 2 here would merge with this 2, and then we combine to a 4. So that's the aim of the game. In terms of that, we decided to break this workshop into 2 parts. Like I said before, the game logic and the Flutter design. So the game logic will be trying to implement using Dart, just how the game will work. What happens if we shift to the left? What happens if we shift up? Can we even move left? Stuff like that. And then next week, Anna will be taking you guys through taking that logic and designing it on a Flutter app. So I'll just get started. And you can, for this workshop, you guys, some of our previous workshops we've used Android Studio, FlutLab. For this workshop, I'm used to VS Code, so I'll be using VS Code, but there shouldn't be any differences. So I'll share a different screen to my VS Code. So hopefully you guys can see this. So I just got VS Code open up, and I'm just going to create a new Flutter project. So what you can do is either go to, you can either on VS Code Control-Shift-P and create a new Flutter project, or you can go on your terminal and just, I believe it's Flutter create, and then you call your app. So I'm just going to call it new app, but you guys can call it whatever you guys want. So it's going to start downloading the Flutter dependencies and all that. And while it's waiting, I'll just go through some of the basic features of 2048. I'm just going to direct it back to here. So one thing I guys want you to notice is that we have a board here, which is this slightly darker brown color here. And we have 16 tiles. Some of the tiles, as you can see, have numbers on them. So we're going to be referring to those as non-empty tiles. And then the tiles which have no numbers on them be called empty tiles. So I'm just going to go back to VS Code and start coding. So after that, you guys can go into the file directory where you created that. So in that case, I created in Dart, and then I believe I called it new app. So your on the left-hand side, you guys should see a similar kind of like project structure. So it'll be right-click on lib and create a new file, and then call it whatever you guys want. I'm going to call mine game.dart. And then on game.dart now, because I did mention the concept of a board and tiles, we're going to be creating classes for them. For those who have done object-oriented programming, this will be exactly what you guys expect. For those who don't know, classes are just a way in programming languages to encapsulate objects. So we're going to create a board class. We're going to create a tile class. And let's think about the properties of what will be in a board class. So like I mentioned before, a board has a bunch of tiles on it. So we want to specify the rows and the columns to let us know how many tiles we will have on it. So I'm just going to type in int row. This will specify the rows we will have on our board, and call for the columns. And we need a constructor for this because we create a class. So we do this in Dart, this.row, this.col. And then we'll do the same for a tile. Now for a tile, we want to specify which row and which column the tile is on. So we'll just call it row, col, and we also want to know the value on the tile because some tiles have numbers on them and some don't. So we're going to just call it a value. And I'm also going to put in a Boolean here called isMerged. This might be unfamiliar for now, but this will come up later in the code. So now that we created a board and a tile, we want to first decorate the board with the tiles. So we'll be having a kind of function that initializes the board for us. So I'm going to call it init board. And I'm going to refer to the instructions here. Sorry, let's bring this on the side. Give me a second. Yeah. So inside our init board, we want to decorate the board with the tiles. So what we will do here is we want to represent the tiles in a data structure, and the data structure we'll be using is a list of tiles. So you can kind of think of it as a 2D array. So inside here, we want to create a list of tiles, and we'll just call it game board. And inside our function, we want to first instantiate it, an instance of it. And then we can think of initializing the tiles onto the board in some kind of nested for loop, just how you would instantiate the things inside a 2D array. So we'll just have a nested for loop going through each of the rows, and then through each of the rows, then add a list in, and then for each of the columns, then add it in, the tiles in. So we'll just have a for loop here. And then for each row, we want to create a new list because do remember this is a list of tiles. Then we want to loop through all the columns. Sorry. Close column. Actually, oh no, I'll call it column. And then now we can specify which kind of tile we want. So here, we're going to add a tile. So if we think about the properties of which tile we have, so we went through each row and then each column. So the row that this tile will be which R value, which index we went through looping our rows, looping through our rows, and then the column will be the index of the column that we loop through. So the row will be whatever the R value is. Column would be whatever C value we have, and the value will be equal. We'll just set it to 0 for now, and then isMerged, we'll set it to false for now. Here, what I should have done was actually create a constructor for the tile, so that's why we have errors there. I'll just create one real quick. So yeah, now we've went through the board. We've decorated the board with 16 tiles, or not 16, but depending on the rows and columns. And now we have tiles on our board. So that's the first part done. And now we're gonna go through the logic of generating tiles with numbers on the board. So I'll share my screen again to go to an example. So hope you guys can see my screen. This is the GitHub repo. If you guys click on part 1 of the GitHub repo, there's also step-by-step word instructions that you guys can follow along here. And if you guys get ahead, you guys can read the further instructions. But I'm just going to talk about generating random tiles. So what do I mean by that? If we go on 2048 here and we make a swipe, let's say, for example, to the left, you will see that a random tile got generated. In this case, this third one. And if I press right again, there will be 4 tiles. So if I press go right, there'll be another random tile. So each kind of state or iteration of the board, we want to generate a random tile. And we want to do that in a function. So in this case, if I go left again, a random tile will be generated again. So now I'll be hopping back onto VS Code. And now we want to create a function which creates random tiles. So what I mean by count here is going to take a parameter count. Count is the number of tiles we want to create. So in this case, back then we only created 1 random tile. So in this case, in that example, count would be 1. But count is basically the number of random tiles you want to generate on the board. So first thing you guys will notice is that the random tile cannot be generated on top of another existing tile. So we want to only create the tile on an empty tile space. An empty tile space is one where the tile has no number on it. So it's kind of like blank, it didn't have a 2 or didn't have a 4 on top. So we want to find out which one of those empty tiles we can actually replace that empty tile with to be an actual tile. So to do that, we will first get all the empty tiles we have. So we'll create a list and we'll call it all empty tiles. Instantiate it. Then we're going to loop through all the empty tiles, or all the tiles in the game, and find out which ones are empty. We'll just do a simple nested for loop. And then if the tile is empty, then we can add it to all empty tiles. So this will be our tile at the rth row and the cth column. We can obviously just check its value to be 0, but in programming, generally we don't really like the concept of magic numbers and all that. So we'll be creating a small function in tile to check if it's empty, and it could be just return if the tile is empty. The value of this tile is 0, then it's empty. So we can replace this with is, and if it's empty, we add it to all empty tiles. So now in this list of tiles, we have all the empty tiles, and now we want to find out which one of those empty tiles we're just going to randomly generate a new tile in. In this case, if we can do a short cut here, if all empty tiles, if it's empty, we just return because there's nothing else for us to do. But if there is something, then we want to randomly choose a empty tile and make it non-empty. And for this, we can hard code it, or we can introduce randomness to it. In this case, I will. So I'm just going to import a package on top called .math, and I'm just gonna import random. So this is basically where from the package .math we're gonna use random. Then we want to go through the number of times we want to generate a new tile that's not empty will be count times. So count plus plus. Then here we need to first instantiate random. That's how the package works. So and we're going to choose how we're going to choose it is we're just going to take a random index. And what I mean by random index, I'll explain it later. So we have a list called all empty tiles, right? And the list will have a length, and the length will be the number of tiles in that list. So we're going to choose a random number from 0 to that the length of that list. And for example, so if the list was, let's say, had 10 tiles, random index will take a random number from 0 to 9 because length is like random will be exclusive. So if we take, for example, the random index to be 0, it just basically means we're going to get the 0th tile in all empty tiles, which will be, in this case, the first tile. And if the random index was, I don't know, 8, it will get like the 8th index, or 7th index, sorry. So random index will be the random number, and now we're going to just randomly get, depending on what random index is, that tile. And then, so this is now the tile we have. And now we're going to change that value to be equals to something. And that equals to be something when you spawn a tile in. There is I believe, a 90% chance it will be 2 and a 10% chance it will be 4. So we'll just use a ternary operator here. I believe it's random.random. Int. So this is a ternary operator. What it's basically saying is we're going to get a random number from 0 to 9. And if that number is 0, the value of this tile will be equal to 4. If it's not, it will be equal to 2. So this is the short. This is just a shortcut of basically saying dot next int 10 equals to 0, and if it equals to 0, then the value equals to 2. And if the value is, and if it's not, then it will equal to 4. Sorry, other way around. The value will be 4. If not, the value will be 2. This is just what we call a ternary operator in programming. So after we do that, we want to remove that tile from all empty tiles because it's no longer empty, because it's an actual tile now. We remove that. So yeah, this function essentially just chooses an empty tile on the board and makes it not empty. Count number of times. That's why I have a for loop here. So I hope that makes sense. If you guys do have any questions, please comment in the chat, and Arnav will answer them, or he will redirect the questions to me. So now these are kind of like the basic kind of functions, and now we're going to be taking a look on how to merge the tiles. So I think the best way to do this is to demonstrate it on the actual game. So I'll switch back to my Chrome tab, and I wrote a short explanation here. But what I mean by merging is, let's say we have 2 here. Merging would be basically, if I go down, I expect these 2 numbers to merge into 4. So in this case, it turns 4. And if I merge left, I expect these 2 numbers to merge to left. And likewise, if I go down, these will become 8. So how we're going to be doing that is basically having an idea of like the dependency order of which column or which row to first merge them from. So I did try to explain it by text, but maybe my explanation in real life will be a bit easier. So if we imagine I'm just going to use shorthand notation, A to be the first row, first columns tile, B to be the first row, second columns tile. So in this case, this 2 here is A, this 2 here is B, this 4 here is C, this 2 here is D. I'm going to try and explain it from this perspective. If we merge left, first we expect B to merge onto A. So B right now is 2, A is 2. So I expect them to merge, and I expect them to be 4. Now B will be 0 because I merged 2 onto 2, and that 2 is gone now from B. That's the first thing that goes behind the scenes. Secondly, now I want C to merge onto B. So the C was 4, B is now 0. So now C will merge onto what B is now, which is 0. And now B will be equals to 4, C will be equal to 0. And then likewise, D will go on to C. So we start off with 2, 2, 4, 2 on the first row. And now afterwards, after one merge, it'll be 4, 4, 2, 0. So you guys might think that we should just merge adjacently. So B onto A, C onto B, D onto C. But in 2048, that it's not as simple as just merging adjacently by one spot. We want to actually kind of like drag all of them to the left. So ideally, we want the logic to be B merges onto A, then C merges onto B, then A again, and then D merges onto C to B to A. And what I mean by that is, let's just say, for example, this tile here, 2, on the second row, third column, is, let's just call it C for now. If I shift it only adjacently by one spot, that 2 will be over here. But I don't want that. I want the 2 to be all the way here on the second row, first column, where A is, essentially. So that's why after we merge this tile here with here, we want to merge this tile here and then here. And the fourth column will be with the third column, then with the second column, then with the first column. So if I get a new instance here, maybe I'll try and find a better example. So in this case, D is equal to 2. And if I press left, I want it to merge with this one, and then this one again. So it pushes all the way to the left and it will be there. So to do that, we're just gonna take a look at how to merge that. That's when I'm gonna introduce the concept of what we created before, the Boolean is merged. I think there is an example here in this section. So before we merged B onto A, which A then became 4, B became 0, and then C merged onto B, which became, so then B became 4, C became 0. And now we want to merge B onto A because we want C, B, A. However, A was already merged before, and we don't want to create 8. We only want to merge once if they changed value. So that's why we have is merged the Boolean. So after B merges with A, we're going to set A is merged to be true. So what is merged is essentially saying is this tile has been merged and no other tiles can merge onto it from now. So when B becomes 4 and wants to merge onto A, it will check that A has already merged before, so it can't merge onto it. So that's why this A doesn't become 8 in the end. It stays at 4 because its merged is equal to true. So now we're going to be turning that kind of logic into code. But just for simplicity, I did explain only when you shift to the left-hand side, but this same logic will be applied if you shifted up, right, or down. In this case, in the example I got here, we're moving up. So B will be merging onto A, then C will be merging onto B, then A, then D will be merging onto C, B, A. And if it's right side, then you can like reverse the direction of A, B, C, D to D, C, B, A. So how that looks like in code is, we'll be having a merge function. We're going to taking two tiles. I'm just going to call tile A and tile B. So we want to check if we want to merge tile B onto A. And to do this, first it will be useful to check if we actually can merge them in the first place, because in the previous examples, there were some cases where you actually can't merge them. So we're going to be creating a function bool can merge. It's going to take tiles, tile A and tile B. So what are the conditions if we can merge them? So we know one is if tile A has already been merged before. So if it's been merged before, then we can't merge it. So if we can merge it, that means A hasn't been merged before. That's one condition. Another condition is if, let's say, A hasn't been merged before and the values are the same. So if I just grab a quick example here, let me try to find one. In this example here, we want to be able to merge B onto A because they have the same two values and A hasn't been merged before. So for that, we will have if if the values are equal, the same. And we don't want it to be empty. That's one condition. Another one is it'll be able to merge if the tile is empty. So in this example, something like this. So we want to be able to merge this number onto this number because A is 0, was empty, and B has a number. So here we will have, I think it's, so we will check if A is empty, and B is not empty. So I'll expand that out. You guys can see that. So we'll be returning that. So now we have a function to check if we can merge it. And now we'll be using that function in the merging function. So first we will check if they can merge. We'll be checking tile A and tile B. And in this scenario, if A has been merged and B is not empty, then we want to put a stop on to saying B can't be merged as well. So an example with this would be, let's say this, 4-2. So no, a better example would be this. So first, B merges onto A, so this will become 4, this will become 0. C merges onto B, so this becomes 4, this becomes 0. And then this has been merged before, so no tile can merge onto A, but now we also want to say no tile can be merged onto B as well. So we're just going to set if that condition is true, then B also can't be merged. And now we'll actually consider the 3 scenarios where you can merge them. The first one will be if A is empty, so we're merging this 2 here onto 0 here. So if A is empty, then A will just take the value of what B was here. So B is 2 here. So it will just be whatever value B is. And then we want to set B to be 0, because after this merges onto that, this becomes 0. So B dot value equals 0. And then another scenario is if the values are the same. So if value then a dot value will just be equal to the values combined. And then we want to set a as merged now. And we want to set b to be 0 now. So that example would be this. So the values are the same. A will become 4, b will become 0. A is merged now, so it can't be merged any further. And then everything else, we just want to say b has been merged because we tried to merge them. So yeah, that will be the merge function. And now this function only considers merging 2 tiles now. So obviously we're not just going to be merging 2 tiles, we want to merge all the tiles together if we can, if we move in a certain direction. So now I'll be trying to introduce you guys to the idea of merging in a certain direction, which will just basically be a for loop. So how we will do this is we'll be having 4 functions, the ability to merge every tile to the left, every tile up, every tile down, and every tile to the right. So we'll be having a function called merge left, and it's going to take a certain row and a certain column. And we'll be basically having different versions of these. And by except we'll have one for right, if we want to merge right, merge up, and merge down. So for now, I'm just going to consider merge left because once we understand the logic for just merging left, you guys can apply it in the same for the other functions. So merging left, maybe I'll keep this diagram here. So we want to first merge this column onto this column, then this column onto this column, onto this column, then this column onto this column, then onto this column, then onto this column. So we're going to be having a while loop. And while the column is greater than 0, so while we don't go out of the board, we want to keep merging everything to its left. So we want to merge the tile on its left with the current tile, RC. And then after that, then we want to -1 because then we're going to shift it onto the next columns. So you guys can maybe think of this first tile here, R and C -1 to be tile A, and then this one to be tile B. So if let's say, for example, C equals to 1 right now, so C equals to 1, so this is the first one. We want to merge tile B here with tile A because C is 1, so then C -1 will be 0, so we're merging with this tile here. And then if, let's say, for example, C equals to 2, you guys can see that it will be equal to C, so C will be merged with B. And then after that, C -1, so then it will be back to merging tile B with tile A. So that's merging left. And then this same kind of logic will be applied for merging right as well. So except we want to go in the other direction, because instead of going from B to A, then C to B to A, then D to C to B to A, we kind of want to reverse the direction. So maybe it'll be easier if I demonstrate it like this. Let's say, so this time we want to go in the opposite direction. B with A, and C with B with A, and D with C with B with A. This time in towards the right. So instead of checking if the column is greater than 0, this time we want to make sure that we don't go out of our columns. So if we have 4 columns, we don't want to go past that number of columns. So it'll just be basically the reverse of checking if we loop out. So while the column is greater than the number of columns we have, then we want to kind of do the exact same. except this time it's C+1. So maybe in this example, this would be like merging B with A. This example, this is tile, I believe, A. This is tile B. Yeah. So let's say, for example, column or C is equal to 3. So it'll be here, B, and call C equals to 2. So this would be tile B here, and we want the one on its right. So to one column on its right. So this would be tile A, which is this one here. And afterwards, we just plus or minus 1. And that's for merging left and merging right. And the same, and still this time we're going by columns. This time, for merging up and down or vertically, we'll be merging by rows this time. So before we were merging column by column, now we're trying to merge row by row. So merging up is very similar. On the GitHub link, it's presented as an exercise for you guys to try out by yourselves. And there will be solutions there. But if you guys are stuck, I'll just you guys here. So it's basically the same as merge left, but this time for rows. So we merge this time by its row. And we also need go down by each row. And merging down, as some of you guys can probably guess, it's similar to merge right, but this time it's by rows as well. So while the R, we don't go out, we want to merge tiles. So that's merging just a single instance of a row or a specified row or column. So now we want to check if we can actually merge them together, not just by, not merging, but if we can actually move every tile to the left, or to the right, or to a certain direction. So before, this checks if we can merge 2 tiles together. Sorry, this function here checks if we can merge 2 tiles. Now we want to check if we can actually move in a certain direction. Move is where we shift every single tile to a specific direction. This one was only for 2 tiles. We want to check for every single tile. So this time we'll be having a Boolean to check if we can actually move. And you guys might be able to predict, but there will also be cases where we also can move right and down. Move up. Yeah, if you guys have any questions, please do post them in the chat. Arnav will check if there are any questions. So for the logic of can move up, it's very, can move left. We just check if 2 specific instances of a tile can merge together. And if they can, then we return true. So we're just going to loop through a simple nested for loop kind of. Equals to 0, C++. If we can merge the game boards, the specific tiles. C, I think it's minus. Sorry, just. We can merge that, then we return true. Otherwise, we return false. Can't, then we return false. However, there's one small thing we had to be careful of. And instead of just starting this at C, we actually want to start it at 1. And I'll demonstrate it as to why here. I grab this picture here. So if it was 0, we want to check if we can merge, if this tile can merge the one on its left. So C is 0. However, you will notice that this will become C minus 1, so -1. But there's no tile that's like on the -1 column. So that's why we start at 1, because it checks if this one, maybe I'll put it back into the one previously. It checks if this first column can merge with this, it checks if the second column can merge with the first column, and then checks if the third column can merge with the second column. So that's why we start at 1 and we're not at 0. Because if it was 0, it will check to the one on the on its left, and there's no tile on to the left of the first column widgets. So we start at 1. And likewise, for move right, we will also, instead of starting at the very right, just on the right -1. So can move right will be kind of similar. Row plus for this time we want to start at the right, not at the left. So we want to go to the very left, very right, but instead of to the very right, we want to just one index to the left, because we don't want to go out of bounds like how we explained here. Instead of column -1, it'll be column -2. Sorry, I keep calling it column. Can merge them. Board R C+1 RC. And I'm just going to tidy up this code because here. So this checks that, sorry, I'm just trying to check if I have any syntax errors.
Yeah, it's like the extra bracket in front of the C+1.
Oh, okay, thank you.
Yeah.
Thanks, Arnold. And yeah, if you can merge it, then return true. And if you can't, return false. And likewise, there'll be on the GitHub repo a short exercise for you guys to implement can move up and can move down in your spare time. But for the sake of this workshop, I'll just be explaining it here. Yeah, it's basically exactly the same, but for rows as you guys can expect. So just like how column here, we had a start at 1, the row also has to be the first row, because we don't want to go to the row above the first row. So then 0. Then if you can merge them, then return true. C. Otherwise, and then yeah, and I will basically copy and paste this here and just kind of change the values. So likewise with move right, this time we want to start at the row of -2. 2 r has to be greater than 0, and then I goes down. And then column will be the same, and instead of this time, it's plus. So yeah, that's can move. Should be it. Sorry. So that's if checking if we can merge in a certain direction. And now kind of like the last kind of major functions we want to implement is actually moving in a certain direction. So now we have functions to check if we can move up, and we have functions to check if we can merge. So I'm just going to create a void move left function, and there will also be a move right and move up. So first, if we can't move left, then we just return because we can't move left. Otherwise, we want to move every single tile left. 0 plus or and C with 0, C col, C plus plus, and we want to merge left. So yeah, and then here we also have a there's a small bug here. Never mind. Yeah. So now I'm going to check create functions that move to right. We can move right. Sorry, if we can't, then we return early. But otherwise, we can just move every single function, every single tile to the right. However, as before we noted, for us to actually move right, we actually first start at the very right and then kind of shift it to the left a bit. So what I mean by that is, if I just use this diagram again, so before left, we start with this tile B with tile A, tile C with tile B. And this time we want to kind of loop in the opposite direction. So we start at the very right, and then we check if we can merge with the tile on its left. So we start at D, and then we merge C with D. And then we decrement down one column, and we check if B merges with C, and then C with D. So yeah, column will start at the very right. Well, 2, just like how before we, sorry, should be -1 actually. We don't want to go out of bounds. And then we merge right. I'll just check for my errors here. So it should be okay. Yep. And then we also have functions to move up and down. So move up, then it'll be very similar logic. If we can't move up, and otherwise kind of go through its rows. Merge up. And likewise move down. Move down. Return early. Otherwise, yeah. sure what happened, but let's create it again. Then loop through all the tiles. This time we want to start at the top, just like and right. So we want to specify down. Then merge down. So hopefully I need a C. So that's moving down, and that's will be most of the main functions we've implemented. I'll just delete this image here, and for some reason this function is return type of bool because I need to put it out. And now we want to kind of add some finishing touches to our game design or game logic. So we talked a lot about just merging kind of like the tiles together. However, you guys will know after you merge in a certain direction, the next iteration, every single tile can be merged again. So we merge once for just that iteration, it can't merge. But after that, every single tile can merge again. So we want a function that kind of resets the is merged of every single tile so that next time you go left or right or up or down, you can merge again. So we're going to create a function called reset merge. And it's just going to something like this. Oh, we'll just call it reset merge state. It just loops through every single tile. So we have our normal nested loop here. Then that specific game board, or sorry, tile, we just want to turn its is merged to false. And I will double check if I did anything wrong here. I think it should be okay. And yeah, and after we move in a certain direction, we want to kind of like call this function. So I'm just going to copy this. So after we make a move, we're going to reset the merge state. So just copy and paste it after every single move. And then after every single move, we also want to generate a new tile because at the very start, I showed how after you make a move, a new kind of like empty tile will be turned into a real tile. So this is an opportunity to call the function we created at the start here, random empty tile, but we only want to create one non-empty tile. So we're just going to call that function here after every single move. So after we move left, we just want to create one instance of it. So we'll just pass in the index of 1. And we add it to all our move functions. So now we're going to add just some more finishing touches on. So right now our game kind of doesn't stop because there's no score system and there's no check to check. There's no kind of like function to check if the game is over. So we're going to first start with the score system. So maybe we can add a score here. I'm just going to go to score. And after we initialize the board, we're just going to set the score to be equal to 0. So we start off at score 0. And then the game will always start with 2 tiles that are non-empty. So we're going to go back and call random empty tile, but instead of just 1 tile, we want 2. So when we initialize the game first, it's going to decorate our board with tiles, and then we're going to be given starting score of 0, and we're going to call the random empty tile function with a count of 2. So it's going to create 2 tiles. And then the last kind of function will be check if the game is over. So we want a Boolean. So we'll just call it is game over. And it's very simple because we created functions to check if we can move a certain direction. So if we imagine how the game would be over, it's if we can't make any legal moves anymore. So we can't move in any direction. We can't move left, we can't move up, we can't move down. So we can't just call every single, I'm not sure why this is here, but we're just gonna check if we can move in any direction. And move left, and move right, and can move up, and can move down. And if we can't do any of these actions, then the game is over. So that's basically the game logic done now. And yeah, so just to summarize, when you start off the game, you'll call init board, initializes the board, and then you can move to certain directions, left, right, or up or down, which will be done by these kind of functions here. And these functions check if we can move in a certain direction first and up, and if we can, then it's going to iterate through all those tiles in a certain direction and merge those adjacent tiles. And these adjacent tiles will merge by this function here. And if we can merge tiles, it'll be checked by this can merge function here. And afterwards, we want to reset the merge state and generate random empty tiles. So that's basically the game design done for today. Next week, Arnav will be taking you guys through the Flutter interface, which is, as you guys can expect, kind of where you guys, well, we introduced at the very start with widgets and stuff like that. So I'll just first delete all this code, kind of give you guys a short sneak peek of what's for next week. In fact, maybe I'll switch to my other VS Code where I actually have the code. So basically today we created this kind of function here. I mean, this Dart file here. And next week we'll be creating a Flutter app, which is just going to start with as a material app. And then we're going to put all our functionalities into this home kind of widget. And this home widget, Anna will be basically just going through with you guys how this kind of home widget works. So just as an example, I will first maybe run the app first. And while I do that, you'll see that on the left, there's also this colors dart. This is kind of optional, but basically this color kind of tile map just basically means that we want our tile 2 to be this certain color, our tile 4 to be this certain color, and stuff like that. So it'll be useful if you guys can kind of like copy and paste this onto another Dart file. So I could just, for example, if I do this and I go back to my previous one, I'll create a Dart file. This is called colors. And you guys just copy and paste that. The code will be on GitHub. If you want to use your own colors, by all means you can. You can like choose your own colors and stuff like that. But these kind of hex codes are just the default 2048 game app kind of colors. So I'll go back here. So while this kind of app is loading, maybe I'll just go through some very small things about what Arnav will be taking guys. So we're going to start with a stateless widget. Then we'll have a stateful widget, which will create a state. We'll have basically a state that gives us the board. And we want to put some implementations on that board. We're going to have a board that displays our score. We're going to have a kind of button that allows us to reset the game. So if we press it, we can start a new game. And then we want to add functionality to it that if we kind of move in a certain direction, it's going to shift the board. So you can kind of see how it's useful to have the game logic where you can just kind of call these functions, move down, move up, that we did in our game.dart. So hopefully, unfortunately, it's still kind of loading. But yeah, oh, I think it's here. Hopefully. It's taking a while. But yeah, next week, there's also some new kind of widgets that we'll be going through, such as the stack widget, positioned widget, yeah, these kind of like basic widgets. So yeah, this is the game. So if I kind of drag down, it's going to drag and it's going to merge. And the colors on these tiles depend on our colors kind of like thing here. So if I change it to like another red color, the tile on 4 will be red and stuff like that. So yeah, this is what hopefully by the end of next week you guys can implement. And that's all from the content wise for today's workshop. If you guys have like any questions, feel free to post them. And otherwise, yeah, I'll stop sharing my screen for now. And then we have a special kind of challenge for today. So usually at the end of our workshop content, we usually have some kind of Kahoot, but this week we decided to keep it with theme, and we actually want to challenge you guys to playing 2048. So I will just go on I'll share my screen again, actually. Maybe that'll be easier. And give you guys some examples of what this challenge is actually about. So if you guys go on to play2048.co, there'll be the 2048 app, and we challenge you to get the highest score you can in 3 minutes. And I'll announce when you guys can start and when the stop time is. And then after you guys do that challenge, please send us an email, which we will post and after probably like 5 minutes. And then please include a screenshot. So the screenshot should look something like this. You should have your game, your score, and we want you to indicate the time you completed it. So in this case, this is just an example, it's 5:03. Yeah, in this case, you can have a score of 0, and we want you to include your time. So yeah, I will officially start the time at 7:09, and we will give you 3 minutes. So please send a screenshot that includes the time at 7:12. So you guys can go ahead and start. This is the link to play.